My name is Emily Mark, and I'll be showing you how to do problem 2006 BC3. This is Calculator OK. Before you do this problem, you'll need to know the equation for the speed of a parametric curve. You'll need to understand both vertical and horizontal tangent lines. You'll need to be able to get the slope from two different parametric equations, and you'll need to be able to set up integrals correctly with initial conditions. The problem says an object moving along a curve in the xy plane is at position x of t, y of t, at time t, where dx dt equals arc sine of 1 minus 2e to the negative t, and dy dt equals 4t over 1 plus t to the third, for t is greater than or equal to 0. At time t equals 2, the object is at point 6, negative 3. Problem A says, find the acceleration vector and the speed of the object at time t equals 2. So to do this, you're given dx dt and you're given dy dt. Now to find this acceleration, because these are both velocities, you'll need to take the slope of each of these, and because it's a calculator OK question, you'll put into your calculator, using your derivative feature, this equation, dx dt, which is equal to arc sine of 1 minus 2e to the negative t. You'll put it in your derivative function where x equals 2. And from that, you should get 0.396. So that's your x value for your acceleration vector. And then you're going to do the exact same thing for the y value of your acceleration vector, except for you're going to use dy dt. So you'll put this exact same thing in, except for the dx dt, you'll write 4t over 1 plus t to the third, where x equals 2. And when you plug that into your calculator, you should get negative 0.741. So your acceleration vector will be 0.396 negative 0.741. And that's the first part of the problem. For the second part, you'll need to find the speed. And to do that, you'll need the equation for the speed of a parametric curve. The equation for speed is the square root of x prime of, in this case, 2 squared plus y prime of 2 squared. Now you're given dx dt and dy dt, so all you'll need to do is plug those two equations in that they gave you and then substitute 2 in for t. So you should write arc sine of 1 minus 2e to the negative 2 squared plus 4 times 2 over 1 plus 2 to the third, and that whole thing is squared too. And if you put that in your calculator, you should get 1.208. And that's how you do part A. Part B says the curve has a vertical tangent line at one point. At what time t is the object at this point? So we know that at vertical tangent lines, the x value does not increase. So you're going to set dx dt equal to 0. So you will go arcsine of 1 minus 2e to the negative t equals 0. You can take the sign of both sides to simplify it. Sine of 0 is still 0, so that will just cross out. So you'll have 1 minus 2e to the negative t equals 0. Now an easy way to find this is using your graphing feature in your calculator. Graph 1 minus 2e to the negative t and graph y equals 0. Then use your intersect feature to find that these two curves intersect at the point t equals 0.693. And that's your answer for B. C says, let m of t denote the slope of the line tangent to the curve at point x of t, y of t. Write an expression for m of t in terms of t and use it to evaluate the limit of m of t as t approaches infinity. So first you need to find the slope of the tangent line to the point at the point x of t, y of t. Since you already have dx dt and dy dt, you need to find dy dx. So an easy way to do that is to just divide your dy dt equation by your dx dt equation. So dy dt is 4t over 1 plus t to the third divided by arcsine of 1 minus 2e to the negative t. And you could just flip this and multiply, so 4t over 1 plus t to the third times 1 over arcsine of 1 minus 2e to the negative t. And it says to find the limit is this approaches infinity. So you want limit as t approaches infinity. So right here, we'll find the limit of 4t over 1 plus t to the third first. You take what's important, so in this case it's your t and your t to the third. This crosses out to be 1, and this crosses out to be t squared. 1 over infinity squared equals 0. Since you're multiplying these two things together, if this one equals 0 and you multiply it by here, you know that the whole limit is t approaches infinity is going to equal 0. And finally, D says, the graph of the curve has a horizontal asymptote y equals c. Write but do not evaluate an expression involving an improper integral that represents this value at c. So for this one, D, you're looking for y, which is equal to c. You have dy dt, which is equal to 4t over 1 plus t to the third. In order to get y, you have to take the integral of dy dt. So you take the integral of here, now in order to find your limits, you need to know where to start. You have an initial condition. Your initial condition is at t equals 2, the particle is at point 6, negative 3. So you're going to look at negative 3 because it's the y value, and so you'll put that as your initial condition. And because it's negative 3 at t equals 2, that will be your lower limit. And then you're going to go to infinity because it's a horizontal asymptote. And This is your answer for the integral of the horizontal asymptote y equals c. Okay, so here's just a quick breakdown of how this question is scored. Part A is worth 2 points. 1 point for getting the correct acceleration, 1 point for getting the correct speed. Part B is worth 2 points. 1 for stating that x prime of t equals 0 and 1 for the correct answer. C is worth 2 points. 1 for correctly writing m of t and 1 for getting the limit value. And Part D is worth 3 points. 1 for having the correct integrand, 1 for having the correct limits, and 1 for having the initial value consistent with the lower limit.